Hey, advanced geometry students, Mr. Donaldson here again, and today we're going to talk about angles. All right, we'll define them and we'll talk about some of the characteristics of angles. So here we go. First things first, this notation looks like a little angle with an arc in it, or this notation, just a little angle. They both mean the same thing. They both mean angle. You can use them interchangeably, and I'll do that as I give the notes today. So an angle by definition is formed by two rays. So I have ray BA and ray BC that share a common endpoint. Both of those rays have a common endpoint of point B. So the vertex of this angle is point B. All right, it is the common endpoint. And the sides of this angle, and this is really important, is the definition of sides or the rays. So when I'm listing the sides of this angle, I have to list rays. Remember, when you're listing a ray, you always go with the endpoint first. So one of the sides of this angle is ray BA, and the other side of this angle is ray BC. Perfecto. All right, so that is the parts of an angle, and now we're going to learn how to name an angle. All right, oops, pretend like you don't see this. I'd filled it in earlier. Oops. All right, here we go. So, how to name an angle. The way we name an angle, and there's three different methods to this, okay? It just depends on the situation. The first and the easiest way you can name an angle is if there's a little number inside of there. And if there's a little number inside of the angle, you could just say, hey, that's angle 1. And if I look at the picture, I know exactly what angle you're talking about. You're talking about the angle that has a little 1 inside of it. All right? Another way you can name an angle is because this is the only angle that I see in this diagram that has B as the vertex, I could call it angle B. Because if I go and look at the picture, and I'm like, oh, must be talking about that angle. That's the only angle that has B as the vertex. A little more thorough way to name angles is by using the vertex and then 2 points that are on the rays. So I could call this angle ABC, or I could call it angle CBA. And if I read that and I look at the picture, I'll be like, all right, angle ABC, start at A through B to C. Angle CBA, start at C through B to A. I can see it's that angle. Really important when you're naming it with 3 letters, the middle letter here must be the vertex. That way I know exactly what you're talking about. Middle letter, or middle point I should say, or whatever, middle letter is the vertex. Very important. Alright, so in this diagram it says name all the angles you see here. Alright? Well, I see 3 angles here. I see angle ABD, or angle 1. So one of the angles is angle ABD, or I can call it angle 1. Another angle I see there is angle CBD, or I can call that angle 2. I would probably just call them angles 1 and 2 to make my life easier. But there's also another angle there. There's this big one that contains both. It's the whole angle. And so I can call that angle ABC, or I can call it angle CBA. But there is no number that represents that one. So I'd have to name it using 3 letters. And I can't call that any of those angles. I cannot call them angle B, because I wouldn't know which one you're talking about. Because there's 3 angles that have B as the vertex. So I have to be a bit more thorough. So I'm going to call this angle A, B, C. So those are the 3 angles that I see in that diagram. All right, next is measuring an angle. The way we measure an angle is the smallest amount of rotation from one ray to the other. So if I look at this angle, I'm not going to measure it by going this long way around. I always want the smallest measure between them. All right? And we measure an angle in degrees. All right? This is an 80-degree angle. And the way we measure an angle is by using a protractor. All right? And I will show you guys in the next slide how to use a protractor. And Ms. Butler makes fun of how I say this word, protractor. I say it weird. All right, the reflex measure of an angle is what's left over from 360 degrees. All the way around the circle is 360 degrees. So if this angle has a measure of 80 degrees, I know its reflex measure, or the rest of this angle measure around it, will be 360 minus 80 degrees, which would be 280 degrees. And then the last thing is notation for how you talk about an angle measure. All right, this reads the measure of angle EGF is equal to 80 degrees. That's how you read that. If you're going to tell me what an angle's measure is, how many degrees it is, you must use the little m. The little m tells me you're talking about its measure. It would not make sense if you said this. This makes no sense. An object cannot equal a number. All right? You wouldn't say Mr. Donaldson equals 6'2". Or, 74 inches. You wouldn't say Mr. Donaldson equals 74 inches. You'd say Mr. Donaldson's height equals or is 74 inches. So you can only talk about equals and numbers if you're talking about some sort of measurement. So the measure of an angle, the length of a segment, the height of a person equals a number. But the object itself does not. So make sure you use that little symbol when you're referring to an angle's measure or how many degrees it is. So here's an example of how you use a protractor. All right, bust my protractor out. So here we go. If I'm going to find the measure of this angle, first thing I'm going to do is I'm going to line up this 0 degree ray down here. I'm going to line that up with one of my rays, or one of the sides of the angle. And then I start at 0 degrees. Now I know that there's two numbers here. You can, if you look at this, you'd be like, well, is it like between 50 and 60 or between 120 and 130? And the way you figure that out is the angle smaller or bigger than a 90 degree angle. And this one is smaller than 90 degrees. So I'm going to start at 0 and go 10, 20, 30, 40. So it's somewhere between 50 and 60 degrees. And I'll look up here and get a bit more precise. And it looks to be right around 57 degrees. Because it's like, here's 50, 55. It's a couple past 55. It's about 57 degrees. So I'd be like, the measure of angle R is equal to 57 degrees. Notice I put my little m there because I'm talking about a measure. All right, now just to show you how the other part of this scale works, I'm going to measure this one by rotating a little bit. And this time I'm going to line up my little ray. I'm going to line up the bottom, the 0 degrees, with this ray of the angle. So here I am, 0 degrees. I'm going to start getting bigger from 0. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. This angle looks to be right around 134, 135 degrees. So we'll say it's 135 degrees. So the measure of angle 3 is 135 degrees. Perfect. All right, next, congruent angles. Congruent angles are angles that have equal measures. Look, these two angles, they both have a 60-degree measure, so they are congruent. So I could say either one of these is true, that the measure of angle A is equal to the measure of angle B, and because of that, if angles have equal measures, it means they're congruent, then I can say angle A is congruent to angle B. So if I ever tell you angles are congruent, it simply means they have the same exact measure. And remember, this symbol is congruent. We discussed that the other day. An angle bisector is a ray that divides the angle into two congruent angles. So suppose I told you down here that ray BD bisects angle ABC. Well, if that is the case, that means that ray BD cuts this big angle into two congruent angles. And the way I can notate that is I could put the same number of little arcs inside. So if you see two angles that both have one little arc inside, you know they're congruent. Or maybe they both have two little arcs inside. You know they're congruent. Or sometimes the book will even put arcs inside with the same number of little tick marks on it. And you know they're congruent. So if you see angles that have the same little markings inside of them, it's intended to tell you, hey, those angles are congruent. And if I see they're congruent to each other, then this ray must be bisecting that angle because it's cutting into two congruent angles. All right, a couple examples. Here we go. First, draw angle BAC being bisected by ray AX. So, let me draw angle BAC. Remember, the middle's the vertex, so A would be here. And I want ray AX to bisect it. So I'm going to draw ray AX the best I can. That was pretty bad. So that well, I keep missing. Let me try one more time. That's better. That it's going like what it looks like to be right down the middle, cutting it in half. And then I'm going to mark that they're congruent by using my little congruency marks. There you have it. I can look at this picture and I know that ray AX is bisecting angle BAC. In the last example here, we're going to start off. It says the measure of angle QRS is 80 degrees. So I'm going to start with an angle that's about 80 degrees. So a little less than 90. All right, so I'm going to say, hey, this whole blue angle, which is angle QRS, this entire angle is 80 degrees. And then ray RD bisects that. So I'm going to draw ray RD. Maybe I'll change colors here. And it cuts this angle into two congruent angles. So I'm going to try to draw it right there in the middle. And that's RD. Now, you guys, I know that if this entire angle was 80 and I bisect it, that each of these little parts are 40 degrees. The next thing says that ray RP bisects angle QRD. So QRD is here, and ray RP, so I'm going to start at R, draw my little bisector, and it's going to go through P. And it bisects this angle. Well, if this angle is 40 and it's getting bisected, then each of these little parts are 20 degrees. So the question asks, find the measure of angle PRS. Well, here's P, here's R, here's S, and from here to here, angle PRS is 20 degrees and 40 degrees, which adds up to 60. So the measure of angle PRS is 60 degrees. Booyah. There you have it. Angles, congruent angles, measures, bisectors, it's all there. So, you guys, hope that made sense. Good luck on your assignment. Let me know if you need any help.